So the other day I was talking to a friend of mine, mentioning I'm going to Qt World Summit, and asking what I should talk about. And she said, "You should talk about hedgehogs. Those are cute." And I said, "Well, yes, but I'm supposed to talk about Qt6." But then I thought, okay, no problem. Don't worry, that will be the last pun for today. I'm not actually here to talk about hedgehogs. I'm here to talk about dragons. Specifically, this little guy called Conky, which is the mascot of KDE. What is KDE, you might ask? KDE is a worldwide community of software engineers, artists, writers, translators, and creators who are committed to free software development. KDE produces the Plasma desktop environment, hundreds of applications, and the many software libraries that support them. Before we talk more about KDE, a little bit about me. I've been contributing to KDE since 2017, and since earlier this year, I'm hired by KDE as the KDE software platform engineer, meaning I'm paid to work on open source software, and I take care of all the building blocks that KDE software is based on, and that includes Qt. In that capacity, I've been sort of leading the transition of KDE towards Qt6, which brought me here to talk about it today. In another job, I also work as a software engineer at KDE, and in both capacities, I have on occasion contributed to Qt directly. This isn't the first time I'm giving a talk like this. The first one was back in 2021 at the Heise Better Code Qt6 conference, where I was talking the first time about KDE's journey towards Qt6. A year later at QDevCon, I was giving another talk like this, and I also gave a keynote about it at the QtCon Brazil. And I've also talked about the topic at various talks at KDE's Academy conference, not to be confused with the Qt Academy. Good thing they don't give out awards like we do. The first thing you need to understand about KDE's code base is that it's huge. The last time I checked, we had about 15 million lines of code, which makes me assume it's the largest code base comprised of Qt code there is in the world. If you know of any others, then talk to me over a beer. Virtually all of that is either C++ or QML code, and back when we started with this transition, all of it was Qt5. KDE is not one big monolithic project, rather it consists of many independent sub-projects that are at least somewhat consistent with each other, but can be a bit diverse. The code is, so to say, multi-generational in the sense that some of it dates back to all the way to the beginnings in 1996. And over time, people joined the project, worked on stuff, then left the project, new people came in, picked it up. So some parts of the code went through 2 or 3 generations of maintainers, which is, I think, pretty impressive from a community point of view. We have both much code that uses widgets and a lot of QML code. And we're going to see a bit why this is interesting from a strategic point of view later. Some of the applications we have are quite graphics intensive in the sense that they do low-level rendering, like Krita, our flagship digital painting application, obviously does a lot of graphics stuff. And our window manager and Wayland compositor also does a lot of low-level OpenGL for compositing. And all of our code is using the CMake build system. Common to almost all KDE projects is that they are based not only on Qt, but also on the KDE frameworks, which are a set of 80-something libraries that are very much inspired by Qt and extend Qt's functionality with solutions for recurring problems, like reading config files, connecting to system libraries, doing file I/O, doing remote file I/O. And those are not only used internally by KDE, but also can be used by other third-party users. And as we've seen in yesterday's keynote from Mercedes, KDE software is actually running in a lot of places where you would not expect that. These frameworks have a strict API and ABI stability guarantee, which makes them very attractive to outside users, but it means that we ourselves are constrained in what we do to them. And the transition from Qt5 to Qt6 now means that it's a breaking change anyway. We might as well break our own API there. So that means we have a once-in-a-decade opportunity to do a lot of cleanup there. This transition is so important to us that we even started to talk about it way before Qt6 was released. The first planning session we had was at the Academy conference in 2019, where Qt6 was announced, and at this Academy, Lars was giving a keynote about what will come for Qt6, but there wasn't actually Qt6 yet. But still, we got together and set out some design principles and goals we wanted to achieve with this transition. The first and maybe most important one is we wanted easy porting without many surprises that are not obvious at compile time, ideally. That very much matches the approach Qt has taken for this transition, which I think is safe to say worked out quite well. Then, of course, we wanted to improve our APIs, drop some old ballast. Like, for example, we finally retired the old and venerable KHTML library that now lives on forever in WebKit and Chromium. Then we wanted to have a better separation between widget-specific parts, QML-specific parts, and logic that is common to both, which also aligns with some of the things that were going on in Qt for Qt6. And traditionally, KDE has been very Linux-focused, but over the time, thanks to the power of Qt, we branched out on more platforms like Windows, macOS, Android, for example, and now, thanks to successful projects like Krita and Cleopatra, most of our users are technically on Windows, even though our flagship product is a Linux desktop environment. So, what has happened since then? During 2019 and 2020, we did a lot of preparation work, improving our own APIs, preparing to deprecate some old API, and generally ported away from deprecated Qt API. Then in late 2020, Qt6 was actually released. So throughout 2021, we got the first proper builds of our software against Qt6. Back then, we still kept the compatibility with Qt5, so we could build both at the same time to be able to keep maintaining and releasing our software based on Qt5 while performing this transition, which in many cases worked out quite nicely. I'm going to come to the big exception to that later. Then earlier this year, we made the decision to go all in on Qt6 for at least some projects, and we're working towards finalizing this transition. Then this month, we released the first alpha release of the Plasma 6 desktop, KDE Framework 6, and an initial batch of KDE applications ported towards Qt6. And the final release of that is planned for February next year. But I'm already running this presentation on my laptop, running a Plasma session based on Qt6. And I have through pretty much all year. There's one particular question that may be on your mind right now. We started to talk about this in 2019, and Qt6 was released in 2020. What took you so long? I'm going to say 80% of the answer has nothing to do with Qt, really. It was purely our own internal APIs that we wanted to iterate on and improve on, and that took a lot of time because we wanted to take things slow and do them properly. The other 20% is stuff that wasn't quite so nice while porting. There's a certain class of problems to port that are not inherently hard or impossible. They just take some time because they appear everywhere. One such example was QRegExp. It's not terribly hard to port it to QRegular expression, but if you have 15 million lines of code, you can imagine how many instances of QRegExp there are, and it just takes a while to port all of them. A very similar story with QStringRef, which was also used in a lot of places, and porting that to QStringView isn't hard. There are some subtleties involved, but it's relatively straightforward. But if you have a lot of them, it takes some time. Another interesting case was QDesktop widget, which is mostly used for querying what screens do I have on my system and what is their size, which is relatively straightforward to port to QScreens. The problem we had in some cases were other creative usages of QDesktop widget, which assumed that it is actually a widget, like grabbing a pixmap from it to do a screenshot, which you can't do with QScreen, and you can't even do in a reliable cross-platform manner at all. Then you probably heard of the changes around the rendering hardware interface, which meant that anytime we used shaders in our program, like the QML shader effect item, we had to adapt that, which is a bit involved, and it goes a bit into a territory that not many people like to touch because they think, oh no, I'm not really familiar with all of this graphic stuff. So that took a while to do properly. And it was also a bit annoying from a build system point of view, because you had to rely on new API that was only available in Qt6. And then we have a fair amount of third-party dependencies that also are built on Qt, and we needed Qt6 versions of all of them, which in many cases was already available, or we were able to port them quite easily, but getting all of them ported and released and ideally co-installable with their Qt5 version took a fair amount of time. Then we also encountered some missing functionality in Qt6. One of the prime examples here is Qtext codec, which was removed from Qt6 in the sense that it was dropped from core and moved into the Qt5 compat module, under the assumption that you only need UTF-8, 16, 32 anyway. But we have applications like a text editor, which ideally should be able to handle every codec you throw at it, and telling your Japanese users that they can't open their Shift.js encoded file anymore because the Qt maintainers decided you should be using UTF-8 anyway is not an acceptable solution to us. So for the time being, our approach was keep using Qtext codec in the compat library, which worked in many cases, but there are still things missing, like you can't set an arbitrary encoding on a Qtext stream anymore because the API for this is simply missing, even if Qt is technically able to handle that codec fine. Another troublesome area was the deprecation or semi-removal of the Qt graphical effects module, which again is still available in the compat library, but it meant we had to adjust our code to actually make use of that. A similar story with Qt X11 extras or platform extras in general. There it was not completely removed, but it was sort of moved privately in a way that we could still make use of it by including a private header, which worked. It made our code build, but now we are relying on private Qt API with all of the implications of that, which is not a great solution from a long-term maintainability point of view. And when porting our QML code from Quick Controls 1 to Quick Controls 2, we found that some components were missing. Like, for example, for quite some Qt6 releases, there simply was no QML tree view that was usable for us. And only with, I think, 6.3, we actually got a proper tree view component that we could use. talking about QML porting. On Monday, I was giving a training on porting to Qt6, and there I said, in QML, both very little changed and everything changed. What do I mean by that? With very little changed, I mean there were very few actually breaking changes in the QML language that required us to adapt our QML code. But in those few instances where there was such a break, it was very hard for us to deal with that in a way that allows us to build against both Qt5 and Qt6. Because take, for example, Qt graphical effects. Like I said, it was moved to the compatibility library, which meant the import name for it changed. So we had to do a different input statement depending on whether we are building for Qt5 or Qt6. In C++, we could do an if-def version check and just include one thing or the other. In QML, it doesn't work that way, because there's no language construct that allows for this. So what we really would have hoped for, or what we would have liked to have, is a sort of if-def version check in QML. This would not only have been useful for this transition, but it can also be useful in minor Qt releases when there's new functionality added that you optionally want to make use if you're running against that specific version. Then Qt is software. Software has bugs, so we found some bugs in Qt. There's nothing terribly concerning about that, it's just part of life. Many of them were found by us and reported by us. Some were even fixed by us directly, contributing to Qt. And ever since it has been possible for KDE people to contribute to Qt, we have done that. And over time, lots of functionality and features from KDE libraries have found their way into Qt. And it's really important for us to be part of the upstream community and contribute our changes there. The lack of a proper open source LTS release was a challenge for us there, because we had this weird gap of Qt 5.15 is closed for any sort of outside development, and we don't really get bug fix releases anymore, so we really should be using Qt6, but we're not quite there yet. So we had to get a bit creative to bridge that gap, which worked out okay. It's not an exercise I would like to repeat. But enough about problems, let's talk about some good things. What are we looking forward to in Qt6? First and foremost, an openly maintained Qt, like I've just said. Then we're looking forward to a much improved Wayland support, because Wayland is a very important target platform for us. We're looking forward to many small but still useful API improvements and additions that aren't really worth mentioning individually right now. We're looking forward to much improved QML tooling and performance improvements in general. So much about porting. Let's look at what the future holds for KDE and Qt. Every couple of years, the KDE community gets together and selects 3 goals that the community wants to focus on for the foreseeable future. Our current 3 goals are KDE for all, sustainable software, and automation. So let's have a look at how Qt helps us achieve these goals. The first one is automation, which is about formalizing and automating some internal processes like code review, release management, community management. And Qt offers tools like QML format and QML lint that can help us automate and consistently quality check our software, which helps us achieve these goals. And both KDE and Qt are both very successful open source communities in their own rights, and there's a lot that we can learn from each other when it comes to building a successful community. The second goal is sustainable software, which is mostly about reducing the energy consumption that is caused by running our software. and by that also avoiding hardware obsolescence, so that you don't have to buy a new laptop just because your programs are running too slow. And how Qt can help here is by performance improvements in Qt that directly improve the performance and resource efficiency of our software. And the third goal is KDE for All, which is about improving the accessibility of our products. I'm very happy that there is lots of activity around accessibility in Qt, and especially Qt6 has a lot of improvements there, but there are still some open issues, like, for example, keyboard navigation in Qt Quick is not as easy to achieve as it is in widgets, for example. Besides these goals, we also have some, I would say, strategic challenges ahead. I've said that porting towards Qt6 QML was both very easy, because very little changed, and then everything changed. What I mean with everything changed is that what we consider ideal, good, idiomatic QML code changed rapidly over the last few years. And we as KDE have not fully caught up with that transition. One issue that we had is that a lot of the tooling and performance improvements in QML rely on the Qt QML module CMake API, which unfortunately is still lacking any support for installing the created module to the file system, which is important when you're developing libraries that ship QML modules as part of their API. We worked around that by basically introducing our own CMake macro that grabs the upstream macro, but I would still like to have a proper solution upstream for this. Then we have lots of legacy QML code that was written 1, 2, 3, 5, 10 years ago that is not up to today's standard. Like, it uses context properties, unqualified property lookups, doesn't use types, doesn't use declarative type registration. And we have a lot to modernize there. And we have some issues with the tooling that is available, like QMLint, QMLLS, and the various compilers, not being able to pick up our own QML module libraries properly for various reasons. Then we have Wayland. If you've been around the Linux desktop, you've probably heard that Wayland is the future of the Linux graphics stack. And it most certainly is the future of the Plasma desktop, but it's also a very important target platform for Qt, not only because of the year of the Linux desktop, but also the prevalence of Wayland in embedded systems. And KDE has been very active in maintaining the Wayland integration inside Qt, to the point where the maintainer of Qt Wayland client is actually a KDE person. So that kind of collaboration makes me very happy, but there certainly is more work needed, both on the Qt side and on the upstream Wayland side, to address some of the missing use cases that Qt has that currently don't work on Wayland. Then we're ever more transitioning away from Qt widgets towards Qt Quick, at least for new applications. But the topic of should I use widgets, should I use QML is somewhat hotly debated and controversial within KDE. And that's because Qt Quick is still lacking a lot of things that makes it a good desktop citizen. Like, for example, there's no support for native pop-ups like dialogues, combo box pop-ups, tooltips, which means everything is constrained to a single window, which is very limiting and really makes applications not feel as native as they should be and as they are with Qt widgets on a desktop system. Then I've mentioned keyboard navigation is harder than it should be, which is a problem not only in general, but specifically for accessibility, which is one of our goals. Then sometimes there's a certain lack of high-level controls. Like Qt exposes a lot of lowish level building blocks like rectangles and buttons, but sometimes you're missing high-level components, like, for example, there's no equivalent of a Qform layout in QML, so we had to roll our own in KDE libraries. Then the fact that widgets in QStyle and Qt style are separate systems is a problem for us, because we like our users to have the ability to use any theme they want, and so to have a consistent experience there, we basically need to maintain two different styles. We have a solution that bridges the Q style to a quick style, but it works surprisingly well, but it has some limitations. And having a better solution for a unified styling approach upstream would be great. Then another issue that we have is there's no unified action class between widgets and Qt. In Qt6, QAction moved from widgets to GUI, which is a change that I like very much, but Qt action isn't actually based on the action class in Qt GUI, which makes it hard to write common code that uses QAction and works with both Quick and widgets. And in general, we found that the developer experience and tooling around QML and Qt is still a bit lacking. For example, the QML type compiler doesn't really support compiling Qt controls, only in a very limited way, which isn't really quite usable for us yet. So, in summary, KDE's transition towards Qt6 is drawing to a close. If you ask me, I would say it went quite smoothly, at least compared to previous transitions like from 3 to 4 or 4 to 5. But it wasn't without issues, but that's completely fair. There is still a lot of modernization work for us ahead, especially on the QML side. And we do have still some strategic issues that we should address. But overall, I think it's fair to say that Qt and Qt6 help KDE achieve its goals. So I want to end this presentation with a slight adaptation of a quote we like to say. We do like to say, Qt6 will fix it, but by now I'd say it's fair to say Qt6 has fixed it. Thank you.